This video looks at interpreting practical problems involving linear graphs. Let's have a look at this first question. Pia is saving money by saving her weekly pocket money. The amount in her piggy bank is shown on the graph below. So let's have a look at that graph. We have our blue line here. We're clearly going up. We have a positive gradient, means that she's saving money every week. So we have weeks on our x-axis, and we have the amount of money saved on our y-axis. Part A, how much was initially in the account? Anytime that you see the word initially in a problem like this, that is when our time, or our x-axis here, is equal to 0. We'll go up and we'll interpret our y-intercept. So our y-intercept here says 30. So that's when x equals 0, y is 30, which tells me initially there was $30 in the account. How much money does Pia get each week? So in order to decide, we will have a look at our x-axis. We'll see there's 10 weeks displayed here. After 1 week, she has $35. After 2 weeks, she has $40. After 3 weeks, she has $45. So as our weeks increase by 1, so as our x unit increases by 1, our y-axis, or our amount of money saved, is increasing by 5. So we have a gradient of 5. That's telling us that Pia gets $5 extra each week. How much does she have after 7 weeks? This one here, because we have the graph, we can just read it off the graph. 7 weeks here on our x-axis, linking it up here, tells us that she has $65 after 7 weeks. If you had an equation instead of the graph, then you would substitute 7 into your x, and you would find out how much your y was, which in this case was how much money she had. Part D, form an equation to match the graph. You should know by now that your straight line equations take on the form y equals mx plus c. So in this case, our y is our amount of money and our x is our time. We need to find our m, which is our gradient, which is how much money she's making each week. And we need our C value, which is how much money she has initially. So just keep that in mind. Your gradient, your M value, is how much Y rises with each one increase in X. So as I said, in this case, that means how much money does she make? How much does Y increase with each one increase in X? In this case, we decided earlier that as her weeks increase by 1, her money saved is equal to $5. So every week she's making $5. That means that's our gradient. C value, that is our y-intercept, or our value when x equals 0, which in this case is 30. So that's going to give me the equation y equals 5x plus 30. Now, keep in mind, if we know what our y and our x are, which in this case we do, we know y is the amount of money and time is our x, we will substitute those values, or those labels rather, into the y and the x, and we will write it as amount of money equals 5 multiplied by weeks plus 30. Lastly, we're going to use this equation to predict how much money Pia has after 20 weeks. So in this case, we want to know the amount of money and we know how many weeks it's been. So we're going to let weeks equal 20 and solve the amount of money. That's going to give me amount of money equals 5 multiplied by 20 plus 30, which gives me $130. All right, let's do one more question and then we're done. A young sunflower's growth is monitored as per the graph below. So again, let's have a look at the graph. It's clearly increasing each week. It looks like here our y value is starting at 20, so our y-intercept is 20, and it's growing here, and we're showing up to 10 weeks. So part A, what is the initial height of the flower? Again, initial height, generally that means our y-intercept. So in this case, initially would mean when our weeks is 0. So no time has occurred yet. Initially, our x is 0, and at that stage, our y is 20. In that case, that means the height of our sunflower is going to be 20 centimeters. What is the height of the flower after 6 weeks? Again, this is one you can read off the graph. Go to 6 weeks here. and we'll follow that grid point up here. And that tells me that after 6 weeks, the height of the flower is going to be here, which is 50 centimeters. Again, if you had an equation instead of the graph, you could substitute that into the equation. Part C, form an equation to match the graph. Again, a linear equation takes on the form y equals mx plus c. So we need to know the gradient and we need to know the y-intercept. We can clearly see from this here that our y-intercept is at 20. So we know our C value. Our gradient, we find our gradient because by definition, our gradient is the value that y increases with every 1 increase in x. So as every week increases by 1, how much is this sunflower growing by? Let's have a look. After 1 week here, it's grown by, it looks like about 5 centimeters. Let's just confirm that by going to the next one. Yep, it's grown another 5, and again, and so on. So each week it looks like this flower is growing by 5 centimeters. That means our gradient here is going to be 5 centimeters. So the equation here would take on the basic form y equals 5x plus 20. Again, if we given the x and the y as worded descriptors, so in this case our x refers to our week number, our y refers to our height of the sunflower, then we would insert those words in place of the x and the y. So for this one here, I'd be writing height of sunflower equals 5 multiplied by week number plus 20, just like so. Part D, use your equation to predict the height after 1 year. So this here only goes up to 10 weeks. After 1 year, we want to know how high it is. We're going to use this equation that we formed in part C. My height equals 5 multiplied by weeks plus 20. In 1 year, there is 52 weeks. So we'd be inserting 52 into this here. That's going to give me 280 centimeters. So we can always use these equations to make predictions. All right, almost there. Here's the equation that we just had from the height of the sunflower. I want us to fill in this blank. When the week increases by 1, the sunflower height increases by how much? So looking here, we should know from earlier that that's increasing by 5 centimeters. Essentially what I'm doing here is interpreting my gradient. Remember, if you're asked to interpret the gradient, you are asked by how much y rises with every 1 unit increase in x. And this might be a nice way of explaining it. When the x increases by 1, the y increases by whatever the gradient is. Okay, so just remember that as you're going through your problems. All right, so for now, you guys can stop the video and you can have a go at the 3 questions in 6G part 2.